When the wagon or trailer of farmer stock peanuts arrives at the buying point, it is weighed on a calibrated scale and the buying point issues a weight ticket. This ticket records the vehicle number, weight of conveyance, and producer information. From a platform above the open conveyance, the sample puller records the conveyance information on a probe pattern card. Identification is very important. The date, probe pattern number, conveyance identification, and the sample puller's initials are recorded on the card. The card is placed into the sample bag and remains with the sample throughout the inspection process. The sample puller collects the sample with a pneumatic sampler following the probe pattern chart. The type and weight of the conveyance determines which probe pattern should be used. The sample is then divided into 2 equal parts. 1. A foreign material sample goes into a container and will be used to determine the grade, or for a routine supervisory check which occurs at least bi-weekly to ensure consistency in grading. The probe pattern card is separated. One section is placed in the check sample bag and the other section continues with the foreign material sample into the grade room. There, it is matched with the load's corresponding weight ticket issued by the buying point. These documents will maintain the sample's identity during the entire inspection process. The inspector enters key information from the weight ticket into the farmer stock program. The entire container of farmer stock peanuts is weighed to ensure the sample's weight meets the minimum 1,500 grams requirement. The peanuts are then poured into the foreign material machine, which separates foreign materials and loose shell kernels from the in-shell farmer stock peanuts. Foreign material includes everything other than peanut kernels, portions of kernels, and in-shell peanuts. Loose-shelled kernels, also known as LSKs, are peanut kernels or any portions of kernels completely free from holes. These are undesirable, since kernels generally store better if they are inside of completely sound holes. The machine does most of the work. However, the inspector completes the sorting by hand. Once the FM and LSKs have been removed, a minimum of 500 grams is removed from the cleaned farmer stock sample. The foreign material and LSKs are weighed, and those weights are entered into the farmer stock program. The LSKs must be visually scanned for A. flavus mold under a high-intensity light. Any kernels suspected of having A. flavus mold are more closely examined with a microscope. This was free of mold and returned to the sample. What would happen if there was visible mold? If the kernel had been positively identified with A. flavus mold, the load would be reported as Seg3. The kernel would be placed in a small bag and identified with the trailer number, date, and SC95 certificate number and held for further examination, if necessary, by the supervisor. After the visual examination, the LSKs are placed into a bag for aflatoxin chemical testing at a later step. The 500-gram sample is then transferred to the pre-sizer, which has rollers that sort the peanuts according to hole size. This machine facilitates the next step where the peanut kernels are removed from the holes by the sheller. Any peanuts that are not mechanically shelled must be shelled by hand, and the holes are examined to remove any peanuts. The weight of the holes is entered into the farmer stock program. The moisture of the peanuts is determined using a calibrated moisture meter. This information is recorded into the farmer stock program. From there, the peanuts are spread over the mechanical shaker screen with 16/64 by 3/4 inch diameter slots. The peanuts and peanut pieces that fall through the screen are collected separately from the peanuts, which did not fall through the slots. Any split kernels that rode the screen are removed, and the whole kernels are weighed and recorded. The visibly damaged kernels are removed from the damage-free or sounds mature kernels, SMK. The peanuts which fell through the screen are sorted to segregate the undamaged split kernels, the damaged split kernels, and the whole kernels. Any broken portions of peanuts which are less than 1/4 of a whole kernel are not counted as splits and are counted as other kernels. Not all damage is visible on the kernel's exterior surface. The sounds mature kernels are mechanically split so that the inspectors can check for concealed rancidity, mold, or decay, commonly called CRMD. The weight of the CRMD is recorded. All components of the sample are sorted and weighed according to the inspection procedure. The other kernels and all damage are also checked for visible A. flavus mold at this step. When all the data has been entered into the farmer stock program, the inspector prints the official farmer stock grade certificate, or SC95. The sample's damaged kernels and the LSKs are reserved for a chemical aflatoxin test when requested. The aflatoxin testing procedure used in this video represents only one type of kit available for use throughout the industry. This farmer stock aflatoxin test begins by grinding the LSKs and damaged kernels. 10 grams of the ground sample are removed, and a buffer pack and distilled water is added. The mixture is shaken for 2 minutes and then left to settle for an additional 2 minutes. Next, dilution buffer is added to a test tube along with 50 microliters of the sample. A test well is placed in the incubator, and the test solution is added. The test strip is put into the well, and the sample is incubated for 3 minutes. The strip is inserted into the reader, and the aflatoxin concentration is determined. For convenience, the test result is recorded on the official grade certificate for the buying point's use. Before the packaging process of a lot begins, the tags are brought into the on-site FSIS grade room. The inspector records the time and date on the control tag that accompanies the grade certificate when it is delivered to the FSIS district office. A second tag is placed on the bag that will hold the check sample, which is retained for 15 days after the lot's production in the event that it is requested for the original inspection to be reviewed. Throughout its production, the lot is continuously auto-sampled. Approximately 100 samples are taken from a standard 44,000 pounds lot, resulting in a total sample size of about 160 pounds. An FSIS employee collects the samples throughout the lot's production and pours each into the divider, separating them into 3 48-pound bags for aflatoxin analysis and 1 16-pound grade sample used by FSIS to create the lot's official grade certificate. It's crucial that positive lot identification, or PLI, is maintained throughout the sampling and packaging process. Each tote receives 2 FSIS-issued tags. One tag is wrapped around the ends of the ties closing the neck of the tote, serving as a tamper-evident seal, and the other is placed in a clear pouch or sometimes sewn to the tote itself. The lot number on the tag links the peanut lot to the official grade certificate, so there can be no doubt that the peanuts delivered are the same as those described on the certificate. PLI is also maintained for the collected samples within the grade room. Each of the 3 48-pound sample bags available for aflatoxin analysis is sewn closed, with the tag clearly visible. A tag also accompanies the grade sample as it's delivered to the on-site FSIS inspector. The entire grade sample is poured into the divider, mixed thoroughly and divided into approximately 2 equal parts. When necessary, the sample is further reduced to obtain the amounts needed for the grade analysis. The excess portion is discarded, and the sample is divided again to obtain the grade analysis sample and the check sample. The grade analysis sample is poured onto the scale and reduced to approximately 1,000 grams to continue the inspection process. The kernel moisture content is measured, and then the sample is placed on the mechanical shaker to separate the smaller kernels from the larger kernels. This separation is achieved by vibrating the peanuts over screens with prescribed openings. The smaller peanuts fall through the openings while the larger peanuts ride on top of the screen. These are referred to as the fall-through and rides. The weight of the fall-through is measured to determine their percentage for the lot. This value is recorded on the grade certificate. To achieve APSA grade, no more than 6% of the sample can fall through the screen. Again, screen size openings vary according to the cut of peanuts being graded. The inspector examines the peanuts that rode the screen, separating out damaged kernels. The splits, broken kernels, and small whole kernels that pass through the screen are separated and examined for damage. All damaged kernels are retained with the check sample for further review if requested. Peanuts are placed into a seed counter to determine the number of peanuts per ounce. The whole kernel peanuts are mechanically split and examined for concealed damage. All damaged kernels are weighed and reported on the grade certificate. To maintain positive lot identification, the official grade certificate is placed into the number 1 sample bag, and the bag is sealed by sewing it closed. The number 1 sample bag is submitted to the USDA-approved aflatoxin lab for testing. Information from the lot's FSIS grade certificate is entered into the lab's information management system. Measures are taken to maintain positive lot identification at all times. Labels are printed for each sample that include a unique lab identifier, the required sample prep and test method. Sample preparation begins as peanuts are poured into a vertical cutter mill and ground until they become a homogeneous paste. 900 to 1,300 grams of paste are taken from the predetermined locations in the bowl, and the peanut paste is weighed to determine the amount of water needed to make the peanut water slurry. A duplicate sample is retained until the sampling process is completed. The sample and its corresponding paperwork are passed from the sample preparation area to the lab for testing. Labware marked with a unique identifier is set up for the sample. Stainless steel blender jars are prepared by marking with a unique identifier, placing the jar on a laboratory balance and tearing the scale. The peanut slurry sample is thoroughly mixed and added to the blender jar. Salt is then added to the sample to improve extraction efficiency. Next, methanol water extraction solvent is added to the sample, which will release any aflatoxin present in the slurry into the sample extract. After blending, the sample extract is filtered through a paper filter to remove the larger particles. The filtered extract is then diluted to volume with water. The extract is mixed well using a vortex mixer and filtered once again through a 2.4 micron glass microfiber filter to ensure clarity of the sample. The final filtrate is immediately measured and added to the testing vessels. Each sample is tested in duplicate and the two results will be averaged. Using a vacuum manifold, the extract passes through an immunoaffinity column at a measured rate. Toxin-specific antibodies in the immunoaffinity column will bind any aflatoxin that is present. The immunoaffinity column is double rinsed with water to wash away any impurities that are present. The columns are marked to indicate that the rinsing step has been completed. Excess liquid is removed with a lint-free wipe before methanol is used to extract the aflatoxin from the immunoaffinity columns. The methanol causes the aflatoxin to be released from the immunoaffinity column, and the aflatoxin and methanol solution is collected in a glass tube to be tested by fluorometer. To enhance the natural fluorescence of aflatoxin, a developer solution is added to the final sample and mixed well. The sample is then placed into a fluorometer where its fluorescence is measured, compared to known standards, and the final result is measured and reported in parts per billion. Data for the sample is entered into the Aflatoxin Lab's information management system, where it is reviewed and approved by lab personnel before a certificate of analysis is released to the customer. The U.S. peanut industry is committed to providing the highest quality peanuts in the world. Each load of farmer stock and every finished lot of peanuts are subject to the safety and quality standards enforced by USDA and federal state inspectors. Positive lot identification clearly connects each lot to its official grade certificate provided by FSIS and the aflatoxin certificate of analysis provided by the USDA-accredited lab. These quality and safety standards ensure that manufacturers, retailers, and the end consumer can be confident that the peanut products they produce, sell, and eat are second to none.